All right, 7-62, trapezoids and kites. Now, I did do the essential question for 7-6 section. Grammatically, it's not quite correct yet. It was even worse in the book from where I got it from. It should read, what special properties do kites and trapezoids have that other parallelograms do not have? All right, so we learned some special properties just for trapezoids, and then we're going to learn a couple today just for kites. Okay, so you can answer it once we're done with today. All right, so we are actually going to pick up where we left off with mid-segments, all right, on Thursday. So we're going to do mid-segments and coordinate geometry. So we have a coordinate grid, we have a trapezoid, and on this trapezoid, we have the coordinates, okay? So here's what it's telling us. It says on the trapezoid of ABCD, we have side AD is parallel to side BC. All right, so AD is parallel. So because it is parallel, I'm going to draw these little triangles on it to show, yep, it's parallel. These two lines are parallel. Okay. And you see the little triangle, it indicates that your lines are parallel. Okay. It wants us to find the end points of the mid-segment. All right, so what we learned on Thursday was that your mid-segment runs parallel to the parallel lines, right? And it cuts the non-parallel lines in half. Now, the endpoints is where it's going to touch the non-parallel lines, okay? So we are going to need to use our midpoint formula to find the midpoint of the non-parallel sides, okay? So AB and BC, these are the non-parallel sides, okay? That's important. All right, so we're going to do the midpoint formula for our non-parallel sides, all right? So AB and DC. These midpoints are the endpoints, okay? So these midpoints are the endpoints of the mid-segment of the trapezoid. Okay, so let's do AB first, okay? So AB. So we are going to find the midpoint of side AB. Now remember your midpoint formula. We're going to add the x and the y's together and divide by 2. All right, so AB, we're going to add the x's together, so 0 plus 18. And then we're going to add the y's together, 8 plus 8. Now 0 plus 18 is 18, divided by 2, that's 9. 8 plus 8 is 16, divided by 2 is 8. So the midpoint, which is also the endpoint of the mid-segment, is at 9, 8. So go to 9 up to 8. Okay. And then we're going to find the midpoint of DC. Midpoint of DC. Okay. And we're adding your x's together, add your y's together, divide by 2. All right, DC, my x's are 1 plus 20. 1 plus 20. First, and then my y's, 4 plus 0. 4 plus 0. My xy coordinate of my midpoint of this line, which is also the end point of the mid-segment, All right, so 21 divided by 2 is 10.5. And then 4 plus 0 is 4, divided by 2 is 2. So 10.5, 2. All right, there's your other endpoint. And endpoint to endpoint, your mid-segment is parallel to your two parallel lines. Okay? So this was simply a continuation. This caused a lot of issues for people in class. A lot of people took the midpoint of the wrong sides. They were taking the midpoint of the parallel sides. So make sure you know which sides are parallel, and then take the midpoint of the non-parallel sides. All right? And remember that your midpoints of these non-parallel sides are the endpoints of your mid-segment. Okay? So you just have to think carefully about these. There's a couple of them. All right? Once you get it, though, it's simple. But you have to remember, you are finding the midpoint of the non-parallel sides. Okay? Seemed to be the biggest trick today. Now let's learn about some kites. Okay? We got two theorems about kites. All right? We've got theorem 1, theorem 1, and theorem 2. Theorem 1 says quadrilateral is a kite, then its diagonals are perpendicular. Okay, diagonals are perpendicular. And what do we know about perpendicular angles? They are 90-degree angles. Okay, if quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So only one pair is congruent. Okay, that's important. Okay, so let's see. We are going to find angles measures in kites. So it says if KLMN is a kite, find the measure of angle N. So we're going to find the measure of angle N. That's what we're looking for. All right, well, we just learned that if quadrilateral is a kite, exactly one pair of opposite angles is congruent. So if these angles are not congruent, then these angles have to be congruent because we were just told it's a kite. Okay? So it says because a kite can only have one pair of opposite congruent angles and K is not congruent to M, then N must be congruent to L so that the measure of angle N equals the measure of angle L. Okay, so now we can substitute in one for the other. It says write and solve an equation to find the measure of angle N. Okay, so if we see the measure of angle L, we can substitute in the measure of angle N for it. Okay, now the polygon interior angle sum. So it's saying that the sum of all four angles is 360. And if you forget how you find the sum of all of the interior angles of any polygon, your formula is the number of sides minus 2 times 180. And it's times 180 and n minus 2 because that is the number of triangles you can make. Okay, and every triangle on Earth has 180 degrees in all three angles added up. So we can make exactly 2 triangles, so 2 times 180 is 360, okay? Not only do you need to know that for today's assignment, you're going to need to know this for the test on Thursday and for the EOC. It's an important equation to know. All right, so let's fill in what we know. Okay, so the measure of angle K is 71. Measure of angle L, we can substitute in the measure of angle N, because that's what we're actually trying to find. The measure of angle M is 52, plus, well, we're just trying to find the measure of angle N, and that equals 360. Okay, we are going to combine our like terms. So 71 plus 52 is 123. You have one measure of angle N plus another measure of angle N. That's two measures of angle N. That equals 360. So we're going to try to find the measure of angle N. We'll subtract 123 from both sides. So two measures of angle N is 237, but we want the measure of one angle N, so we're going to divide both sides by 2. The measure of angle N is 118.5 degrees. Okay, so don't forget, in your summary area, you're going to write a summary for 7-6's section. All right, on the back, we're going to do a little more exploring with our kites, okay? And we're also going to use the fact that the diagonals form perpendicular lines, which are right angles, and they form 90-degree angles. We need to know that. Okay, so we have this kite back here. All right, and we're going to find lengths on this kite. Now we must remember that the diagonals form perpendicular lines, which makes this, what? A right triangle, right triangle, right triangle, right triangle. Okay, so a kite is made up of 4 right triangles. And if we're missing a side, because it wants us to find the length, we can use our Pythagorean theorem. It keeps popping up. All right, the Pythagorean theorem, for those of you who need a reminder, it is a square plus b square equals c square, where a and b are your legs, and the legs form the right angle. Okay. Now c is always your hypotenuse. The hypotenuse is across from the right angle, but it never forms the right angle. It's the slant, basically, of your right triangle. Okay, that's basically what it says. It says because the diagonals of the kite are perpendicular, they divide A, B, C, D into 4 right triangles. You can use Pythagorean theorem to find AD. Okay, so that's what we're finding in part 1 is AD. Okay, it wants us to find AD. All right, that's what we're looking for. Okay. The length of the hypotenuse of a right triangle, AED. Okay, so we have our legs and we have our hypotenuse. So AE is 12 squared plus ED is 24 squared equals AD squared. So 12 squared is 144. 24 squared is 576. And what you end up with is 720. Now we don't want AD squared, we want AD, so we're going to take the square root of both sides. Now something that McGraw-Hill and your EOC is going to ask for is it asks you to simplify in radical form, simplest radical form. So we are going to still have a radical in our answer, okay? And the reason why we're going to do this is because we have a couple more parts and we're going to use the number and it gives a more accurate number. All right. When you have a radical still in your answer, you can treat it just like a variable. And so we'll get into that in a little bit, okay? So let's see. We want 2 square roots. Okay, a square root times a square root to equal the square root of 720. Okay, so here's what you're looking for. You're looking for at least one perfect square and times a non-perfect square. Okay, so this is divisible by 5, and 5 is a non-perfect square, okay? And 5 times what gets you to 720? Well, that's 144, and that is a perfect square. So we're trying to pull out as many perfect squares as we can and leave a non-perfect square under the radical. Okay, so the square root of 144 is 12, the square root of 5. That equals AD. 12, the square root of 5. We can use the square root of 5. We can just treat it like a variable. I'll show you what I mean by that a little later. Okay, so if AD is 12, the square root of 5, then CD is also 12, the square root of 5. Okay. Now it wants me to find the perimeter. Okay, for finding the perimeter, we're going to add up all of our sides, but we're missing a couple of sides. All right, so it wants us to find AB. It wants us to find the hypotenuse now of AB. Okay, we'll find the hypotenuse of AB of this right triangle. All right. So it says from the figure we know that AB is congruent to BC and AD is congruent to CD, so AB equals BC. Okay, and AD equals CD. And we know that AD is 12, the square root of 5. We can use the Pythagorean theorem to find AB. So what do we know? We can fill in what we know. We know AE is 12 squared. We know EB is 6 squared, and we're trying to find AB squared. So A squared plus B squared equals C squared. So 144 plus 36 equals AB squared. This is 180, but we don't want AB squared. We want AB. So those cancel each other out. Now again, we want a simplified radical form, okay, because this is not a perfect square root. So we're looking for the largest or as many perfect squares as you can pull out times a non-perfect square, okay, equals the square root of 180. We're going to see if the square root of 5 works again, okay, because then we'll have like terms that we can do something with. And so 180 divided by 5, well, that's 36. Now the square root of 36, that is a perfect square, because that is 6, the square root of 5 equals AB. So 6, the square root of 5. Now that's 6 the square root of 5. This is 6 the square root of 5. Now since all of these have the square root of 5, again, we can treat these as if they were a variable, and our answer is going to have the square root of 5 in it. So let's do the perimeter. So these are the same, so you can take this one and multiply it by 2, and you can take this one, multiply it by 2, add them together. And that's what they're talking about here. Okay, so we're going to take 2 times AB plus 2 times AD. So that's what we've done. All right, so 2 times the value of AB, which is 6, the square root of 5, plus, okay, the value of 2 values of AD, which is 12, the square root of 5. All right. So we're going to distribute the 2. So 2 times 6 is 12. Square root of 5 plus 24, the square root of 5. Treat those just like variables, okay? And then add them together and you get 36, the square root of 5. Okay, again, treat them just like variables. All right, we didn't do anything with the square root of 5, but since they were both had the square root of 5, we were able to add them together, all right, because they were like terms. So your perimeter is 36 square root of 5. Your assignment is not as complicated as this, but again, a lot of people were stumbling with this part here of finding the midpoint of the non-parallel sides. That seemed to be a sticking point for a lot of people, so make sure you reference your notes. And then good luck, you've got this.